Hello, welcome. I, Kokila, will be your host and speaker for today. This session is organized by Infometry. We are a pure play data analytics company based out of Vermont, California, with our offshore development center in Bangalore, India. We came to inception back in 2010, and since then we have been offering domain specific analytic solutions for high tech, energy, life sciences, retail, manufacturing, and finance customers. Being a data analytics services and solution provider, we focus on delivering predictive and prescriptive analytics, AI/ML solutions, cloud data warehouse implementation, data governance, enterprise service bus, microservices-based integration solutions, big data, cloud DevOps, Salesforce CRM, and product engineering, etc. Infometry has been an engineering and consulting service partner for companies like Snowflake, Google Cloud, Informatica, MuleSoft, Databricks, Fivetran, AWS, Tableau, Adaptive Insights, Microsoft Azure, Matillion, etc. Moreover, Infometry has developed 22 plus Informatica cloud connectors and Snowflake native apps with pre-built connectivity to NetSuite, Salesforce, and Marketo, enabling real-time analytics across Snowflake, Google BigQuery, Amazon Redshift, Databricks, and Azure Synapse. One mentioned under Blue Blocks are developed and owned by us, and the rest are developed by us only for organizations like Informatica, Slab, Calidus, etc. We have developed state-of-the-art analytic solutions, InfoFiscus, which can be hooked to any on-prem or cloud CRM, ERP, or planning apps. InfoFiscus is 100% cloud-based pre-built analytics software developed using open architecture. InfoFiscus comes in three different flavors: finance, supply chain, and sales and marketing analytics. We are delighted to announce the launch of the next generation InfoFiscus Snowflake native applications featuring pre-built connectivity to NetSuite, Salesforce, Marketo, and more. These applications enable seamless integration and real-time analytics. That's our quick introduction, and now let's move to our today's agenda. In today's introduction to Today, we will discuss Apache Iceberg and how it is transforming modern data lake architectures. We will begin with a quick introduction to Iceberg, understand its architecture and file format, then explore different catalog options including Snowflake managed and external catalogs. Next, we will see how Iceberg works natively inside Snowflake, discuss setup and configuration, review performance, optimization techniques, and finally look at real-world business use cases before moving to question and answers. By the end of this session, you will understand why Iceberg is becoming the standard table format for open lake architectures. Apache Iceberg is an open source table format designed specifically for large-scale analytics and data lakes. Traditionally, data lakes stored files directly in S3 or ADLS, but managing schema changes, updates, deletes, and historical versions was difficult. Iceberg solves these challenges by introducing a metadata-driven architecture. Some key capabilities include ACID transactions for consistency, schema evaluation without rewriting data, partition evaluation, time travel capabilities, multi-engine interoperability. One of the biggest advantages is that Iceberg is an open format. Unlike proprietary storage formats, your data remains accessible from multiple query engines. Today, organizations can query the same iceberg table from Snowflake, Apache Spark, Apache Flink, Trino, Athena without copying the data. This eliminates vendor lock-in and enables a true Lakehouse architecture. To understand Iceberg, think of it is a three-layer architecture. Layer 1, catalog. This catalog acts as an table directory. It stores references to the latest metadata file and serves as a source of truth. For example, Snowflake catalog, AWS Glue, Hive Metastore, Polaris catalog. Layer 2, metadata layer. This is the brain of Iceberg. Instead of scanning millions of files, Iceberg uses metadata files containing schema information, partition details, file locations, snapshot history. Whenever data changes, Iceberg creates a new snapshot rather than modifying existing files. Layer 3, data layer. This contains the actual data files, typically Parquet, ORC, Avro, stored in S3, ADLS, or GCS. Since data files are immutable, accidental corruption risks are minimized. This architecture is what enables time travel, rollback, and high performance query pruning. Let's see catalog types. Let's compare the major catalog options available. Snowflake internal catalog, best when Snowflake is the primary analytics platform. Snowflake automatically manages metadata, manifests, and snapshots. Very easy to administer. AWS Glue catalog, common for AWS based data lake environments, works well with Athena, EMR, and Spark. Polaris catalog. Polaris is Snowflake's open source catalog designed specifically for multi-engine interoperability. It provides governance while remaining open. Hive Metastore, a traditional Hadoop-based metadata service, still widely used in legacy big data environments. When choosing a catalog, consider primary query engine, governance requirements, multi-engine access needs, existing ecosystem investments. Iceberg in Snowflake. Snowflake has invested heavily in Iceberg support. The architecture is simple. Data remains in S3 while Snowflake provides compute and metadata services. The process consists of three components: external volume, catalog, query layer. Snowflake can read Iceberg tables, write Iceberg tables, create Iceberg tables using CTAs, load data using copy into. A major advantage is that Snowflake users can continue using familiar SQL while leveraging open storage. Features such as time travel, dynamic tables, Cortex AI, governance policies can all operate on Iceberg tables. This gives organization the flexibility of a data lake with the reliability of a data warehouse. Setup steps for Iceberg in Snowflake. Let's walk through the process. Storage integration. We create a storage integration object in Snowflake. This establishes trust between Snowflake and AWS using an AIM role. No credentials are stored inside Snowflake. Step 2. External volume. Next, we define an external volume. This this points to the S3 bucket location where Iceberg data and metadata will reside. Think of it as Snowflake's connection to cloud storage. Step 3. Iceberg table creation. Finally, we create the Iceberg table. We specify catalog type, external volume, storage location. Then load data using create table as select, copy into insert statements. From this point onwards, Snowflake automatically generates and maintains Iceberg metadata. Users can query the table exactly like a native Snowflake table. Security and governance. Security and governance are critical for enterprise adoption. Iceberg integrates well with Snowflake governance capabilities. IAM role-based access. Snowflake assumes an IAM role whenever it accesses S3. This eliminates the need for storing access keys. Snowflake RBAC. Standard role-based access control continues to work. Examples: analyst, data engineer, admin can have different permissions. Row and column security. Sensitive information such as PII, financial data, healthcare records can be protected using masking policies and row access policies. Auditability. Because Iceberg maintains snapshots, organizations can track who changed data, when changes occurred, historical states. This is extremely useful for compliance frameworks such as GDPR and HIPAA. Use cases and real world impact. Let's look at some practical use cases. Financial services. Banks use Iceberg for risk analysis and regulatory reporting. Time travel allows auditors to inspect historical data exactly as it existed on a specific date. Healthcare. Healthcare providers benefit from immutable audit trials and strong governance controls. E-commerce. Retail organizations combine streaming customer events with historical purchase data for personalization. IoT and telemetry. Billions of device events can be stored efficiently in Iceberg and processed using Flink or Spark. Government. Open data initiatives benefits from multi-engine access without data duplication. Multi-cloud organizations. Companies running AWS, Azure, and Google Cloud can maintain an unified Lakehouse architecture while avoiding vendor lock-in. Summary. Let's summarize the key takeaways. Apache Iceberg brings warehouse-grade reliability to data lakes. The major benefits include open architecture, ACID transactions, schema evolution, time travel, multi-engine compatibility. Snowflake provides first-class support for Iceberg, enabling organizations to combine Snowflake's powerful compute engine with open cloud storage. For successful implementations, remember, choose the right catalog, design partitions carefully, use IAM-based security, regularly compact small files. Ultimately, Iceberg helps organizations build scalable, most effective, which are cost effective, and future-proof Lakehouse platforms. That that concludes the presentation. We have covered Apache Iceberg fundamentals, architecture, catalog choices, Snowflake integration, governance, performance, considerations, and real-world use cases. I am happy to answer any questions regarding Iceberg architecture, Snowflake implementation, catalog selection, performance optimization, real-world adaptation strategies. Thank you.